All right, this is the fourth block of topic 24. In this lesson, we're going to be able to make connections between surface area and volume of prisms and cylinders using both tables and graphs. So remember Dee's problem we've been looking at recently for her search for a cylinder that has a volume of 64 cubic centimeters, but that has the smallest possible surface area. So some things for us to think about are how many cylinders exist that have that certain volume of 64 cubic centimeters, if we're not limited to whole number dimensions. Well, if we can have decimal and fractions as our dimensions, there's really an infinite amount of possibilities here. So if the surface area is changing with different values of the height and radius while we're maintaining the same volume, how can we find the cylinder with the least amount of surface area? That's what we're going to be looking at. So Dee made a table to keep track of some different values for the radius and height. So you can see her first column here is R for radius, her second column is for her height, and her third column is for surface area. So she first entered the radius and height values that she discovered earlier. 2 for the radius and 5.09 for the height, and 2.02 for the radius and 5 for the height. Let's go ahead and find the surface areas to fill in for those two amounts. So let's look at putting that into our calculator. So we know surface area is 2 pi r squared. So we'd have 2 pi times, we're using 2.0 for our radius first, and don't forget to square that. Now you could put 2 squared, that's the same thing, plus 2 pi rh, so 2 pi times our radius of 2.0, again is the same thing as 2, and we're using 5.09 for our height. And I believe we're rounding to the nearest tenth, so we have a 0 in the tenth spot, the 9 next door makes that become a 1. So we should have 89.1 square centimeters for our surface area on that first one. So then for the second one, if you want to be lazy, you can scroll up and highlight that and press enter and just go and make the changes that you need to. So 2 pi r squared, instead of 2.0 squared, we want 2.02 squared. So I'm going to enter a 2 here. That's 2.02 squared. And so then I have 2 pi r, I'm going to insert a 2 here. Oops, I entered it in the wrong place. How about here? Our h and our height is just 5.0, so I'm going to delete that 9 at the end. So rounded to the nearest tenth, we get 89.1 again for this one. Okay, so you can go ahead and fill that in on your notes for both of those surface areas, 89.1 square centimeters for both. So what I want you to do is to go through and fill in your chart for the rest of these amounts. Now be careful how you find your height. So for instance, on the 1.8, I want to show you how most students would enter it, which is incorrect. So your height is 64 divided by pi r squared. You cannot just put it in here as 64 divided by pi times our radius, which in this case is 1.8 squared. That is incorrect. You're going to get the wrong height there. The problem is your calculator thinks you just want to divide 64 by pi and then multiply that answer times 1.8 squared. And that's not what we want. So I'm going to go up here and highlight this and bring it down and insert what I need. I need parentheses around this denominator. So I'm going to insert a parentheses here, and then at the end I'm going to put a parentheses here. Now my calculator knows I want to divide 64 by this entire product, and that will give you your correct height on that. Okay, so go through and fill in your table, and then you can restart this video once you have that filled out, and we'll check it. Okay, so these are the results that you should have gotten in your calculations. So Dee asked Penny, does this agree with her findings? And Penny replies with a wink and smile. So we'll look at what she means by this. So go ahead and answer question 3 in your notes, which says, since you know the cylinder will have a volume of 64 cubic centimeters, you can write the equation, and if you have one of the old notes, you'll need to make this change on your notes. It says 2 pi RH equals, but that's not the equation for volume. It's pi r squared h equals 64. So solving that equation for h and substituting it into the formula for the surface area of the cylinder, we can then simplify to create an equation for the surface area in terms of r. So go ahead and try to do that. Solve pi r squared h equals 64 for h, and then put that in for h into your surface area formula. So do that real quick and then restart the video. Okay, so in our chart we found that the minimum surface area we found so far is a radius of 2.2 and a 4.21 height, and it gave us a surface area of 88.6, which was the smallest of any in our table. So on number 3, if you start off with the formula for volume, pi r squared h, oh good night, can't write, pi r squared h, and we want our volume to be 64, that we can solve this for h by getting rid of the pi and r squared. Since this is all multiplication, to get rid of it we would do the opposite, which is division. So dividing both sides by pi r squared is where we get the value of h to be 64 divided by pi r squared. So then we can go into our formula for surface area and replace the h with 64 over pi r squared. So we can see that this is what we got when we divided both sides by pi r squared. And so we can go to our surface area formula, replace h with 64 over pi r squared. So these two numbers are in the numerator. We can multiply those together. 2 pi r times 64 would be in the numerator over pi r squared. And let me move this right here. So you can see the pi in the numerator and denominator will cancel. R over r squared is simply 1 over r. So we don't have a pi and r in the numerator anymore. 2 times 64 is 128, and all we have in the denominator is r. So once again, let me make sure you understand what happened there. The pi's canceled, and r over r squared left an r in the denominator only. 2 times 64 is 128. So this is the formula for surface area that only has r in it. It does not have the h in it. So let's look at how that is going to be helpful. So now we can put, since we only have one variable, we can put this into our graphing calculator. So in your graphing calculator, you're going to go to the y equals, and you're going to put in that formula. So I'm going to write it here so I can see it. So it's surface area equals 2 pi r squared plus 128 over r. So we're doing this in our y equals. Now we don't have an r as a variable, but we're going to put x, but we're just going to know that x is standing for the radius. So in my y equals, I'm going to put 2 pi r squared, and instead of r I'm using x, so x squared, plus 128 divided by r, and again I'm using x instead of r. So we've got that into our y equals, and we're going to change our window to these values right here. Now remember, let's talk about why we're changing our windows to that. So go to window here. The x, remember, is our radius, and so we can't have a negative radius. So that makes sense that we're starting with 0, and we're just going up to a radius of 5 to see what it looks like. Don't change your scale typically. The y in this case is my surface area, so again, surface area can't be negative, so we're going to start with a minimum of 0 and go up to a surface area of 150. So we have changed our window. So once you have this into your y equals and you've changed your window, you can sketch your graph for number 4 in your notes. So go ahead and look at the graph by hitting graph and sketch that on your notes. So hit graph and sketch this here on your notes. So you can see you've got a curve. It's not really a parabola. It's not symmetrical like we look at with parabolas. So don't try to make it into one, because it is not. It is a curve, but it is not a parabola. So here's our graph. That's what we looked at. Now, just like you did with quadratics in Algebra 1, we're going to find the minimum value. So to do that, you're going to hit second trace, because in blue above trace it says calc, and we're going to do a calculation. So press second calc. We want the minimum value, so you're going to press number 3, because that's what we're trying to do, is find the minimum surface area. Now, if you'll remember from Algebra 1, when it says left bound, it's wanting you to move your cursor to be on the left side of where you know the minimum is. So my minimum's down here, so anywhere on the curve on the left side of your minimum is good. And press enter. And then it'll ask for right bound, so you're going to hit the right arrow till you're clearly to the right of the lowest point. And then it'll ask you to guess, and you can just press enter. You don't have to actually guess. So it's giving me my minimum value. Remember, x is my radius, y is my surface area. So you can see those answers here. So you can tell we're a little bit different than what they got as answers here. I don't think that's their minimum. I think they just have their cursor right there for now. So in answer to the question, we already answered this. Does this graph look like a function family you've studied before? It kind of looks like the quadratics you've studied with parabolas, but again, this is not symmetrical, so it is definitely not quadratic since it's not symmetrical. And we looked at the process of finding the minimum. Okay, so we can write that minimum, by the way, down on your notes. The x, remember, is your radius. So your radius is approximately 2.2 centimeters, which makes your surface area approximately 88.6 square centimeters. And by the way, always make sure you see it saying minimum right here so that you don't think you're not writing something down that's not the minimum value. So like if I just look at the graph and I go to second trace, or let's not even do second, let's just do trace. A lot of students will do this. They'll just move their cursor and they'll write down stuff. Well, you don't want to guess at where the minimum is. Always go through that process. Second trace 3, and then go to your left bound, right bound, guess, and enter. So it will say minimum when you actually have the correct value. So if you don't see the word minimum right here, don't write that down as your answer. So it says, how can we repeat this process to find the height that minimizes surface area for a prism with a square base that has a volume of 343? So if we want to find the height with a radius of 343, that just means over here, anywhere we had 64, we would replace it with 343. So just a different volume is what we're looking at there. Now this solved for the radius. If you wanted to solve for the height, then you would need to get solve for r, so you can replace r with your height. So back here we would have pi r squared h equals 343, and we would solve for r. So we would have to divide by pi h and then take the square root and then replace r in the formula. So then everything would be in terms of height. So then when we put this in our calculator, the x would stand for height. All right, so D decides to go with those measurements of a radius of 2.2. The way that she figured height to be 4.2 is, of course, just going back here where we had height equals 64 divided by pi r squared and replacing the radius with 2.2. So 64 divided by pi times 2.2 squared is where she got that height of 4.2 centimeters. So after doing some double checking with that radius and that height, she found that her volume's really going to be a little bit less than 64 cubic centimeters. It's going to be 63.86 cubic centimeters to be more exact, but she decides to use the dimensions anyway. But she'll have to claim on the container that it's only 63 cubic centimeters rather than 64, since it doesn't really have that. So meanwhile, it says Penny notices an interesting connection when she compares her notes for the rectangular box of sugar cubes with the discoveries that she and Dee have made with the cylindrical container of granulated sugar. So with the rectangular box, she determined this formula